All right, so this is the last example for section 2.4. And for this example, it's number 71, and we're going to find the equation of the tangent line to the graph of the function at the given point. So again, this is section 2.4 is the section we're on, and it's dealing with chain rule. You're going to have to use chain rule to find the derivative of this function, since I have a square root and then there's an inside function, the 2x squared minus 7. So for tangent line, recall that the slope of the tangent line is given by the first derivative. So slope m is equal to f prime of x, and we'll call it f prime and fx with the subscript 0 for some point x0 comma y0. So this is going to be some fixed point. So we got to find the derivative. Plug in the x coordinate of the given point into the derivative to get the slope. And then after we find the slope, then we can form the equation of the tangent line. So last, form the equation of the tangent line. And I use point slope form because it's just less to work. So point slope form of a line. It's y minus y1 equals m times x minus x1. So there's point slope form, the slope-intercept form. We're familiar with slope-intercept form is the form that we use most of the time as far as in previous algebra classes, and it's y equals mx plus b. And then there's the general form, which is, for some odd reason, the textbook for this example, they did the general form. In the general form, ax plus by plus c equal to 0. This is what the textbook answer is, but we usually never do the general form. And then I usually go with point slope because it's less steps. All right, and so, I mean, either way, there's three different formats. There's point slope form, slope-intercept form, and general form. Whichever one you feel most comfortable with. So recall that slope's the derivative of the function evaluated at the x coordinate of the point that's given. All right, so our function is the square root of 2x squared minus 7. All right, so that's the strategy. So I'm going to go ahead and work out the problem now. All right, so solution. First thing I'm going to do is represent it. We know square root is the same thing as raising to the 1/2. So f of x is going to equal 2x squared minus 7 raised to the 1/2 power. And to find its derivative, I have to use chain rule, or the general power rule. And the general power rule is this, and in this case, u is 2x squared minus 7. So u prime, derivative of 2x squared minus 7. So that's going to be 2 times the derivative of x squared, which is 2 times x. And then minus 7, that'd be plus 0, because that's a constant. So u prime is 4x. All right, that's what u prime is. That's what I multiply it by. That's the derivative of the inside function. All right, so f prime of x. So right now I'm applying this relationship. I had the power part of it, so I drop down the 1/2. So it'd be 1/2 times 2x squared minus 7 raised to the 1/2 minus 1. Now I multiply that by the derivative of the inside function, u prime, which was 4x. And then I simplify it, so f prime of x. So 4 times 1/2 is 2, so I have 2x, and then 2x squared minus 7 to 1/2 minus 1 is negative 1/2. So I would bring this to the denominator. So it becomes positive 1/2, and we know 1/2 is the same thing as taking the square root. So I could just write this as 2x over the square root of 2x squared minus 7. All right, this is the derivative. I need to find the slope now. So that's the first step, is finding the derivative. So the slope, m, is equal to f prime, and then whatever the x coordinate is of our point that's given in the question. And the point we're given is 4, 5. So we're going to plug 4 in. All right, so we plug the x coordinate in. That's going to be equal to 2 times 4 over the square root of 2, and then times 4 squared minus 7. All right, so simplifying this down, so 2 times 4 is 8, so I have 8, and then the square root. So what is this going to be? 4 squared, 16. 16 times 2 is 32. 32 minus 7 is going to give me 25. So you're going to have 25 as far as this whole thing, which we know that's 8/5. So the slope is 8/5. All right, so from there, I'm on my last step. I just need to form the equation. So, and again, I use point slope y minus y1 equals m times x minus x1. And so my slope is 8/5. I'm going to, the point that they give you in the question is 4, 5. So I use this for x1, y1. So it'll be y minus 5 equal to 8/5 times x minus 4. All right, and that's going to be the answer. That's the tangent line. And again, this is point slope form for it. You could rewrite this in a slope-intercept form. If you put this in slope-intercept form, you'll get it to be y equals 8/5 x, and then minus 7/5. So that's another possible answer. The textbook goes further, rewrites this into general form, and in general form, it turns into how they have it as 8x minus 5y minus 7 equal to 0. The textbook's a little inconsistent. Again, I'm fine with all three formats. Which one you feel more comfortable with, that's fine. Know that for the textbook, that sometimes their answer might be in something looking like this, and that's the general form. And notice I have 8, -5, and -7. They use whole numbers. So they have it as ax plus by plus c. And then a, b, and c, they make them to be whole numbers. All right, so that concludes the section. That was just an example where you find the equation of the tangent line. And so we've dealt with finding the equation of the tangent line before. It's just this one we had to use chain rule for finding the derivative. So again, the steps are you find the derivative. After you find the derivative, you get the slope by plugging in the x coordinate of the given point. And then the last thing is to find the equation itself of the tangent line. And point slope form is easiest because you just plug the coordinates in like right here, and then I'm done. That's the equation. You could have rewrote this into the slope-intercept form, and then you could rewrite that, it's again into general form. So all three of these are equivalent answers. All right, so that's it for section 2.4. The next section is going to be section 2.5.